Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate if we collect a bunch of data, we take samples of a population, we can create frequency charts, relative frequency charts, and we can graph that data using a histogram. By adjusting the scales and looking at our histograms, we can notice some trends. First of all, our data could skew one way or the other. So this is an example right here of a graph that skews to the right. The graph down here, this would be an example of data that's skewed to the left. So what this means is, if you can imagine underneath here, we'd have all this little data, all these little histograms, right? Okay, and it's skewed one way or the other. What this means is that these graphs don't have any symmetry about them. But there are instances where the data could turn and have some symmetry. So if you increase your sample size to 100, to 1,000, 10,000, and then you take that interval, the horizontal interval on your histogram, and you decrease it, so you make it more fine-tuned, more intricate, more detailed, your data could start to resemble what's called a normal curve. A normal curve has a lot of characteristics about it. It is bell-shaped, as you can see, and it is symmetric to the mean of the data. If you have data that resembles a normal curve, then we say we have a normal distribution. Normal curves can be narrow, they can be wide, but they're all symmetric to the mean of the data. Let's add some more notations here. Remember, a normal curve means your data is normally distributed. That means it is symmetric to the mean. Well, the mean is in the middle here, the mean of the data. So we have to have some vocabulary here. If you're talking about the mean of a population, then you could use the symbol mu. If you're talking about the sample mean, right? So you take a sample and you find its mean, then we use x bar. Most of the time you use x bar here on the mean. Next, your data gets spread out evenly on both sides. That's one of the characteristics about a normally distributed set of data. Remember, the mean right here acts as your line of symmetry. How your data is spread is called your standard deviation. Standard deviation can also be represented using different variables depending on what we're looking at, whether we're looking at the population or the sample. If you want the standard deviation for the population, we use lowercase sigma. If you want the standard deviation for the sample, we just use the variable letter s. The value of your standard deviation does influence kind of the shape of your normal curve. So if your standard deviation is a very small number, then what that means is that your data is more tightly clustered. It's closer to the mean. If your standard deviation is a large number, that means your data is much more spread out, which means it is spread farther from the mean.